On today's episode, a great figure for Transonic Flight. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. I recently reported on the progress of one of the more interesting of the aerospace startups, Boom Supersonic. Now, this Colorado-based company is aiming to create a 21st century Concorde, an aircraft similar in capacity and form as the original supersonic airliner, but with far greater efficiency and profitability for airlines. Now, the renderings show a truly beautiful airplane, as Concorde was. An overhead look at the planform, however, shows a wasp-waisted fuselage, something that keen aviation observers have seen before in military aircraft such as the Northrop T-38 and the Republic F-105 Thunderchief. And there's a reason for this. Back in the 1950s, when jet engines were anemic, supersonic flight was very difficult to achieve. In fact, one manufacturer, Convair, made a prototype of a jet fighter designed to be supersonic, which simply couldn't get through the sound barrier. Now, the problem was solved when the company consulted with an NACA engineer named Richard Whitcomb, who, along with some earlier researchers, determined that there was a proportionality between transonic wave drag and the cross-sectional area of aircraft, largely independent of the overall aircraft shape. Now, where the wings meet the fuselage, of course, the cross-sectional area increases considerably. Reducing this cross-sectional area by narrowing the fuselage locally reduces drag in the transonic regime, so much so that with added afterbodies on its tail, it allowed the Convair F-102 jet fighter to fly supersonically. For higher Mach numbers, a supersonic area rule is applied, similarly requiring careful shaping of aircraft fuselages and engine nacelles. Now, for the Boom Supersonic Overture airliner, a key design feature is supercruise, that's supersonic flight without the use of afterburners. Now, this puts a premium on aerodynamic efficiency since the airframe can't simply blast through the transonic regime with the surplus of engine thrust. Now, the complex curvatures required are very expensive to produce in a metal monocoque airframe, but Overture is made of composites, and there's little to prevent a composite structure from existing in almost any desired shape and at low cost. In the 1950s, that Marilyn Monroe look allowed early jets to break the sound barrier. In the 21st century, Boom Supersonic is using it to get a big, 80-seat airliner above Mach 1 with dry, medium bypass ratio turbofans. This could make the dream of Concorde's designers, that is regular supersonic passenger flight, a reality. Well, that's it for today's episode of End of the Line, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.